Okay, we're going to do the notes for 8.4. We already know the procedure for solving equations. We had it in Chapter 7. You eliminate the parentheses. You combine any like terms. You gather everything with the variable to one side, everything without the variable to the other side, and then you divide if you need to. So we've had those steps for that procedure. We're going to use the exact same thing. Unfortunately, it's just going to get a little uglier because we're dealing with decimals. So we'll start off fairly simple. So look, what's happening with the A? Well, we're having 3.02 being subtracted. So we are going to add 3.02 to both sides. Notice what I'm doing. On this right-hand side, I'm lining up my decimals because I'm going to have to add. And I'm going to get A is equal to, well, the decimal in the answer is going to come right below. 7 plus 2 is 9. 3 plus 0 is 3. And 7 plus 3 is 10. And your answer is A equals 10.39. So the procedures are exactly the same. We're just adding the fun of having the decimals here. Look at this one. It's a one-stepper. What's happening between negative 0.8 and y? They're being multiplied. I undo that by dividing by negative 0.8. And of course that 0 doesn't have to be there. You can put that there if you want to. So these will cancel. Y is going to be equal to, all right, now we got to do a division problem here. So I'm dividing 0.8 into 5.4. I'm not going to deal with the signs. I know I'm dividing a negative by a negative, so I know my answer is going to be positive. Now this one, look, the divisor has a decimal, so I move that over 1, which means I move this over 1. So I like to write a new problem here. You don't have to. I'm going to put my decimal there, and I'm going to add a couple of zeros just in case I need them. The decimal in my answer is going to go right up there. So 8 goes into 54 6 times. 6 times 8 is 48. Subtract, you get 6. Bring down the 0. 8 divides into 60 7 times. 7 times 8 is 56. Subtract, you get 4. Bring down a 0. And 8 goes into 40 5 times evenly, and you're done. So your y is going to be positive 6.75. All right. I am not a decimal fan, so I am not enjoying this one bit, just so you know. But we're going to get through this. In fact, we're almost done with this. All right, so look what C has that we haven't dealt with before. C has parentheses that we have to get rid of, and we're going to do that by distributing. So 3 times x is 3x minus, well, what's 1.4 times 3? 3 times 4 is 12. Carry my 1. 3 times 1 is 3 plus 1 is 4. Since there's one number to the right of the decimal, I move my decimal point back one place, and I get 4.2. Okay, now I have variables on both sides of my equal sign, so I have to move everything with the variable to the left-hand side. So that means I don't want this 2x over here. How am I going to get rid of that positive 2x? I'm going to subtract 2x from both sides. 3x minus 2x is 1x minus 4.2 equals negative 5.9. Okay, now what's happening with the x? We're having 4.2 subtracted. How do I undo that? I'm going to add 4.2 to both sides. X is going to be equal to, okay, now look, what do I have to do here? I'm adding two numbers with different signs, which means I'm going to subtract them. subtract the absolute values, and the answer will be the same sign as the larger absolute value number, which is this one. So my answer is going to be negative. My decimals are lined up, and I'm going to subtract these. 9 minus 2 is 7, and 5 minus 4 is 1. So my answer is negative 1.7. Always remember all those rules that we had a long time ago for positives and negatives. They still apply. All right, here we go. We need to get the x alone. Now notice everything with a variable is already to the left-hand side. So what's on the left that I don't want? I don't want this negative 1.8. How am I going to get rid of subtracting 1.08? I'm going to add 1.08 to both sides of my equal sign. Those are going to cancel. Notice how I lined up my decimals here. So I have left 0.02x is equal to, if I add these decimals, I'm going to get 8, a 6, and a 2. So 2.68. Now, what's happening with these two numbers? They're being multiplied, so I'm going to divide both sides by 0.02. Those are going to cancel. X is going to be equal to, all right, I'm going to have to use some scrap over here because now I'm going to have to divide 0.02 into 2.68. There's a decimal out here in the divisor. I'm going to move that over 2 places to the right, which means I'm going to move this guy over 2 places to the right. So what I really have is simply 2 into 268. And that's going to go in evenly 134 times. So the answer is not a decimal in this case. It's simply 134. All right. And finally, we have a story problem. Great. Let's see what this says. Tam must fill his vending machine with change. From past experience, he knows that the number of dimes he needs to place in the machine for change is 3 times the number of quarters. So the number of dimes is 3 times the number of quarters. The total value of dimes and quarters for change is $4.95. How many of each coin must Tam put into the vending machine? Follow our procedure. So our procedure, remember, is make sure that you read the whole story problem all the way through. We did that. Now, this is not a problem where we can draw a picture. So we're going to have to go ahead and define our variables. Well, what are we looking for? We're looking for the number of coins, the number of dimes, and the number of quarters. So the number of dimes and the number of quarters. So we're defining our variable. And don't forget, one of them has to be x. So let's see if we can figure out what that is. Well, what does it say is the relationship between the number of dimes and quarters? It says he knows that the number of dimes that he needs is 3 times the number of quarters. So the number of dimes is 3 times the number of quarters. So that means that our quarters are going to be x and our dimes are going to be 3 times, or 3x. Okay. Now we have to set up the equation. Take very careful notes because this is a little tricky. The total value of dimes and quarters is $4.95. It does not say the total number of coins, the total value. So what you have to remember here is that each dime is worth 10 cents and each quarter is worth 25 cents. So watch what this equation has to be. 3x, that's the number of dimes, but each dime is worth 10 cents. So there's the total value of the dimes. Here's the number of them times 0.10 or 10 cents. Plus, now we have to have the total number of money for quarters. So that's going to be x times, what's the value of a quarter? 0.25. So there's how much money in quarters we have. And we have a total of $4.95. So that's tricky. Take very careful notes. Okay, so now let's multiply these. Well, what's 3 times 0.10? Well, that's just like having 3 dimes. So that's 0.30x plus, I'm just going to flip these around, 0.25x is equal to 4.95. What's the deal there? I can add these together, and 0.30 plus 0.25 is 0.55x equals 4.95. We're going to divide both sides by 0.55. Those are going to cancel. Now we have to do some division, so I need to do 0.55 into 4.95. Move the decimal 2 places, move the decimal 2 places. So now it's really just 55 into 495. Well, how many times does 55 go into 495? I believe it goes in 9 times, evenly. So that means x is equal to 9. Now, what did I just find? I found the number of quarters. It says how many of each coin does he have to put in there. So he has to put in 9 quarters. That's x. And then how many dimes? Well, that's going to be 3 times 9, or 27 dimes. And I think if you were to add up all that money, you would get $4.95. And there's the end of notes for 8.4.